Well, thank you everyone for joining in. This is GitHub for Beginners, as in just basic Git concepts about Git, explaining about it, and just walking through a process to be able to create a first pull request in a GitHub repository, basically. So just something to consider, just remember there are no dumb questions. We were all beginners once and may still be also to some extent, right? We're always learning. So just feel free to ask questions at any time. Interrupt me. I will be rambling on as I usually do. So feel free to unmute yourself and interrupt me at any time if you have any questions. And then we also have the chat as well. If you just want to put questions in the chat, that's fine too. Hopefully somebody will ask me because I'm not looking at it right now. Basic agenda of what we're going to go through here. So I'm going to talk a little bit just explaining what is Git and GitHub. And yes, they are two different things. So I just want to make sure to clarify that just in case there's any confusion around that. I'll also just quickly show the steps to just install Git and get it sort of set up on your machine. I don't think I'm actually going to do it myself in the interest of time. I'll probably just like go through these, and then at the end, we'll just walk through the basic steps of the flow of creating a pull request in GitHub. And there is a sample repository. It's actually something that somebody else made that I'm borrowing from, where they actually go through a full tutorial of what I have here. I've just included details of every step that they've said, what it actually means, just in case it's not clear. So starting off, so what is Git as opposed to GitHub, right? So Git is a distributed version control management system to keep track of code as it's changed, worked on by a group or alone if you're by yourself in your own little GitHub repo, right? That's cool too. So the idea is you want to keep track of your code changes. You're able to, with something like Git, you're able to like go back to a previous version of your code if you want to. If you didn't like a certain direction you went in, you want to go back. It allows you to do all kinds of things. And it's very useful when you're working on a team of people and everybody wants to contribute to like a shared code base. That's where it becomes useful. So that's Git. Now, GitHub is actually a company. I think it was founded back in 2008, I believe, but now it's owned by Microsoft, got acquired by Microsoft recently. And it is a company that makes tools that integrate with Git and provides a platform so that you can actually work on code bases using Git as the version control, like using Git to keep track, as I mentioned before. So two different things. It's just GitHub is a company that uses Git. So you don't need GitHub to use Git because there are other companies out there that also provide, like Bitbucket from Atlassian is one, and Azure DevOps from Microsoft also provides Git repos. And there are other companies that provide that facility similar to GitHub. But in order to use GitHub or to put any code there or anything, you need to use Git. So that's the difference between the two. So to start off with, if you want to contribute to GitHub or work on any repos, either your own or somebody else's, you do have to install Git on your machine. So these are just different commands depending on your platform, Windows, Linux, or Mac. Now, I tend to go with the package manager, so that's what these commands are. But this link here actually does link you to installers if you want to just, install it on your machine. And at the very end, you can do git -- version. You can run it in a command shell, essentially, to make sure that Git is truly installed on your machine. And then you can see what version it is. So the next thing is you do need to set up a username and email because it always tags on a username email to everything that you basically commit. And I'll explain what that is in a minute, but everything that goes into a Git repository needs your username and email. So this is just kind of the steps to walk you through that, how you actually do that. And at the end, you confirm that you have truly set that up for yourself. The other thing you need is a way to authenticate to GitHub in this case, because you'd want to work with an actual Git repository. So SSH, you can think of it as a replacement for a username and password, where you generate a key on your machine with this command. And generally, SH keygen is usually there by default on the operating system, I want to say. So you should be able to just run that command, generate a key following these steps. And then at the very end, you do have to go through a process to apply that in GitHub. So you do need to create your own GitHub account. So you go to their website and just sign up over there for free. And then once you do that, you do also need to make sure that your email address is verified, because as I mentioned before, on your machine, not register, but you set up your Git client with an email. So you want to use the same, make sure the same email is in your GitHub account as well. So that way it's like linked, right? Every time you want to put anything in GitHub. And then these are just the steps to, once you generate the the SH key that I mentioned before, that needs to also go into GitHub. So there's a concept of you have stuff on your machine, and that needs to be like synced in a sense with what's in with setting it up in GitHub, so that they know how to basically talk to each other when you want to push code. All right, so ready to make the first pull request. So going through that process. So this is the link to the repository that I used, which is this right here. And I thought this was a very nice step-by-step way of being able, like they've basically made this repository in GitHub so that you can know what it means to actually make what's called a pull request, meaning you want to make a change to the code that's in their repo and present it to them for review. That's what a pull request is for. And then they would say, yep, it's good. We want to take it into our code base and we're going to merge it in. We're going to get it in, basically. So this walks you through that whole process step by step, every command that you run with Git. And it just makes you make a very small change to a markdown file, a text file, just add your name in there that, yes, you've done this, basically. And at the very end, it shows you like, this is how you make the pull request. And once you do it, it will automatically merge it in. They have a bot running or something that actually merges it in for them as well. So just going through those steps, step by step. So the first thing that needs to be done is whenever you work on any repository in GitHub, I would say this is more of a GitHub flow to do the forking that's mentioned here. Typically when you're at work, typically everybody is like considered a contributor to the Git repository. So you would just directly work with it and not do this step. But this step is more for when you're working in open source projects in GitHub, you would do this part. So Git Fork means what you're doing is there's a serve, there's GitHub, which is the company, and they have their servers out there that host all these code bases, repositories, as they're called, Git repositories. So when you do a fork, what you're doing is you're making a copy of that Git repository that person A has made in technically their GitHub account. You're making that copy in your GitHub account. So that's what a fork means, as in like you're forking or making your own copy of the code. It's called forking it. So this is your copy that you have, and that way you can do whatever you want to it and it won't affect the original at all. It's truly a copy. But what's important is to understand is it is on the server. Nothing has come to your machine just yet. So when you click the fork button in GitHub, that's essentially how you make a copy, and you will see it show up in your account, your GitHub account. It will show as a repo that's forked from the original. The next step is now you need to download that onto your machine. The copy of the entire repo comes to your machine. That's where the distributed version control management system concept comes from. So you're actually getting the whole repository in your machine, and you can work on it without like being connected to this internet or the server or anything. It works in a disconnected mode. That's how Git works. So with Git Clone, you actually clone the repo down to your happy Git client over here on your machine. So that's Git Clone. And then the next step, if you want to generally make any code changes, the first thing you always do typically is make a branch. So Git Checkout and then -b means, so I guess let me back up a little. So this is usually a representation of how you see Git. It's like every what should I say? Everything that's done, I guess, to the Git repository is called a commit. So each of these little bubbles here represents a commit, and each one points to the next and points to the next. And it's like a linked list of commits, I guess, if you will. So, and there's always one called master or main. You'll see it that way. Sometimes it's referred to as trunk, and that's why we branch. So these are all like old version control concepts of a trunk as like the main source of truth in essence. And then you create branches for any features or bugs or anything that you're working on to make a change to that code base. You do it in a branch to isolate your changes. And that's why in Git, you basically make a branch out. So this part can actually move on forward. Like, you know, if I'm working on a change and Charmaine's working on a change and Isabel is working on a change, everybody will have their own branch and they can merge it as what is called into like into main at any point in time, whenever they're ready to like get it into the main code base. And once you do that, I can actually get that again, like update my version, so to speak, of the repo with whatever changes have gone forward. So I'm not going to go into that stuff today, but just to give you an idea of what it actually means. So once you download that onto your machine, you make your branch. Now you're ready to actually do some changes. So whatever changes you make, whatever files you change, add new, delete, what have you basically have to do git add. There's a concept in Git about an unstaged and a staged area. So the idea is whatever whatever changes that need to ultimately make it into the ultimate code base, into the ultimate repo, it first needs to move from an unstaged to a staged area. So any changes you make all go into unstaged automatically. Git basically keeps track of any changes to files. Even if you add a space, it's going to see it as a change and it will be tracked, right? So everything gets tracked and comes into an unstaged area. And before you can actually, I guess I should say commit, but before you can say, okay, I'm ready to actually now start getting this into the repository, first you have to do git add in order to move it into a staged area. So the that, and then git status is a command that lets you see what the state of your repository is. So you can see what's in unstaged, what's in staged. It also shows you if things are modified or deleted or new, whatever. So it kind of shows you the status of your repository at the time that you run the command. So the next step after that is git commit. So git commit, one thing to realize with this is it is local. Nothing has moved, nothing has actually gone to the server just yet. It is completely still on your machine. You're still working locally only. So git commit, the idea of that is you want to give a description of what it is that you've done. Typically, you should try to give some sort of descriptive message. So this is probably an example of what you shouldn't be doing. But the idea is if we ever look back in history and there are commands like git log that lets you go back and see, okay, what did I do yesterday or a week ago or whenever, you can go back and see. And if you look at the code changes, have no clue why the heck you did something, at least hopefully the commit message will at least tell you this was the reason you did it, even if it was not a good reason. So, and then you can backtrack it if you want to. But anyway, so that's git commit. At this point, you have basically said, okay, this is now another commit on the repo. So it becomes that kind of little bubble I showed before where it will show up as another thing, but it's still in a branch. So it'll be a commit in a branch off of main. So if you're looking at any sort of a visual UI of this, which there are many tools for that, that's how you'd end up seeing it. That's how it ends up being depicted to you. And then when you're finally, now one thing also I want to mention before getting to pushes, you can actually do as many commits as you want. So what's nice about Git is you can keep like, yeah, I need to make changes to this file and this file and this file and this file, and remove this here, move this there, all this kind of stuff. You can do all of that and you can make as many commits as you want. So you can go as granular as you want in those commits. Like you can do one file at a time, or you can do 2-3 files, or the whole thing and then one big ginormous commit. You can do it any which way you want. It's completely up to you. what's nice about trying to commit as often as you can and being as granular as you can is it's very easy to then backtrack because it is literally keeping versions of your code and still locally too, right? So nobody else can see it except you. Um, so typically you want to try to commit as often as possible, but yeah, I mean, it's a bit of a discipline to get into that mode of being able to do it very frequently. But you can have whatever you want in your commit. There's no rule or limit or anything like that. But that's all local so far. So now we get into Git Push. So Git Push is you're ready to put this in your fork. Remember, you had made a copy at the very beginning of your repository, at least in GitHub, made a copy of the um, repository for yourself. So this push would happen to your fork. You would be pushing from your client machine up to the server, up to GitHub in this example, since we're talking about pushing to GitHub. So you do git push. Origin is usually, it's called a remote, but basically it represents, it's a representation, a URL essentially, to the fork repo that you made on GitHub. And then in this case, I name my branch awesome changes because obviously they are. So that's why you do the branch at the end. And it will create this branch on the server in your fork. You will see it in there when you look in the GitHub UI. You will actually see this branch pushed just a minute ago or a few seconds ago or something like that. So now they're actually there and you're at a point that you can actually open what's called a pull request. So the idea of the pull request is now that you made your awesome changes, you want to get your awesome changes into the original repository. Remember, you had a copy. So the pull request is basically saying, can you please pull my awesome changes into your original awesome repo, right? That's the idea of the pull request. Now this is purely, pull request is actually technically nothing to do with Git. It is actually a concept from, I want to say it originated in GitHub, but I don't know for sure. But the idea is there's two copies because remember we did the fork before. So you want to actually get your copy into the original. And this is like an open source concept, right? Because with open source, there's a main original repo that people are kind of maintaining, but they want to open it up to any person out there to be able to put changes in. So the person who wants to get their changes in is saying, can you pull my changes? And that's why it's called a pull request. You're requesting to pull your changes in. So in GitHub, this is the process where once you see it in the UI that you have pushed that branch, they'll give you a button there like this, like compare and pull request. So you basically get a UI that will show you, so it gives you a place to give a message. Again, you want to give context as to what you've done so that the person on the other side who gets this will basically be able to do a code review using GitHub because it shows you all the differences, all the files that were changed, everything. All that is in the UI, right? They can also pull down that particular branch. I think, pretty sure you can pull it down and run it local if you really want to see like how it's going to work out or something like that. So that's the idea. And at the very end, you create pull request. That's how the person can review it. And once you make a pull request, ultimately the person's like, yeah, this is good to go. There'll be a merge button there that they can click and it will become another commit in that original repo at this point in time. So that's basically how it works. Yay. So just to recap, these are all the commands that I walked you through today. This is basic commands that you'd be using pretty much any Git repo, not necessarily GitHub related. Remember, this is like Git that we're talking about here. So any kind of GitHub repository, not GitHub, sorry. See, I said it too. Any Git repository that you work with, you would generally use these commands. That's how it would work. Now, there's a lot more other commands that for today, I don't know if there's enough time or not to go through some of these things, and I'm happy to explain which each of these things are in more detail, but these are more commands related to seeing history, being able to backtrack the previous version if you want to. There's also rebase versus merge type stuff. Fetch and pull is for updating your original, updating from the server down to your machine, because you do have the separation of the repository on your local machine versus the repository that's on the GitHub server, that kind of thing. And then these are a few resources I added at the end, which I thought, so the cheat sheet is nice for just those commands because I never remember them. I actually always use a UI personally. I'm just so used to using a UI, but getting used to the command line is actually good if you can. But I think the UI helps the most when you want to see history of stuff, because I don't think GitLog does enough justice. So that's where, and visually seeing, like, especially when you're working in a team and everybody's working their own branches, and you kind of want to see what other people are doing or what happened, or go back 6 months and see what happened to the specific file. That's where a UI, a GUI client is useful. And if you're using Visual Studio Code, they also have like good extensions that you can use as well. So let's see. So, and some of these are a little more like advanced tutorials. This is a good one, I thought, to sort of visually see how the branching works, and it sort of walks you through some exercises. So if you want to understand better, I think about like rebase and merge and those kinds of concepts, a little more advanced concepts with Git. I thought this was a good thing. So I added some of these resources that I felt were useful for me as I was like learning and understanding about Git. So hopefully can be useful for you too. And yeah, that's all I have for today. Hopefully this was helpful for you and you will now be able to contribute repos in GitHub. I hope so. So yeah, feel free to ask questions later if you think of them, or run to issues or something. I'm in the Python Slack. I'm also CloudTrack Slack if you want to join in there. Um, but yeah, that's basically all that I have for today.
Wonderful. We do have a question that came into the chat. It's, if you plan to commit very often to keep a granular record of your changes, how often should you push? If you're just pushing to your own repo, how often should you push?
Totally up to you. The advantage of pushing is, again, when you commit local machine, but when you push, it's on a server. And that server usually will be like disaster recovery, high availability, all the good stuff that makes sure that that will be there, right? But your computer, local computer, you may not necessarily have the same resiliency, right? So that's where you want to try to also push, especially since it's your fork in this scenario. You're doing a fork, you're doing your own copy. So I don't think you have to push after every commit. That seems a bit too much to me, but I would think, let's say, you're working for a span of 3 hours, I don't know, making it up. At the end of it, once you feel like you're good, might be good to push, or before you walk away from your computer, go ahead and push, right? So the idea is you have a copy of whatever you've done on a server out there that GitHub will make sure that, they don't lose your code base, but you could easily lose your code base in your machine if, I don't know, your computer gets hosed or something like that, right? So no real good, it's sort of what makes sense for you, I think, in your flow. But that's kind of what I'd use as a rule of thumb. Maybe just when you're ready to actually be done for the day, might be good to just push. That's usually, I think, if I think about how I do it, I think that's how I do it. As far as workday is concerned, I'm usually pushing at the end. And to be very honest with you, I don't always push too, because sometimes I just don't really want other people to be able to see, because once you push, anybody can see it. I mean, well, with GitHub, you can have private repos, so that's there too. But I mean, at work, our GitHub repo, all my whole team can see, right? So sometimes I may not, but yeah, I would say pretty much when you're ready to sort of dial down for the day or something might be a good rule of thumb. I hope that answers the question.
So we have another question. Why is GitHub used so much in open source if GitHub itself is not open source and there are other open source options?
Wow, that's a really good question. I think I'm trying to think about like historically, right? I feel like GitHub was there for a very long time, and all the other ones that I mentioned were more for corporate. They were not free, so you couldn't like just get and make a free account and start sharing code. I think GitHub got into that space of code sharing and all that kind of stuff, social coding, right? That's what they call it as, very early. And by the time anybody else sort of came in the space, like GitHub was already there for many years. And the whole thing about that is, where do most people go, right? When you talk about social, just in general too, most people tend to flock to a certain area kind of thing. So I think that's what happened with GitHub. And that's why, and they also made it so easy, I guess I should say in quotes, air quotes maybe, but they did make it easy to actually like get in and start and share and really help spearhead the open source movement. I think, I'll be honest, this is my personal opinion, of course. But that's what I feel somehow about why it's so popular.